For this activity, we're going to use an Arduino Uno to control an LED. In the previous activity, we added a push button to the LED circuit so that we could control when it turns on and off. But what if we wanted the LED to turn on and off automatically? To accomplish this, we're going to use the Arduino Uno. An Arduino Uno is a miniature computer. You can think of it as a simpler version of the Chromebook that you're using to view this video right now. It can be programmed to do pretty much anything you can think of. What makes it different from your Chromebook and most other computers that you've probably used is that it is very easy to make your Arduino Uno interact with external electronic circuits. For the rest of the class, we will be using your Arduino Uno to act as the brain for your project. It'll be able to make decisions and perform actions based on how you programmed it. For this activity, you'll need your Arduino Uno, a USB cable, a 1 kilo ohm resistor, an LED, and some jumper wires. In the previous activities, we used a 5-volt source from the Arduino Uno to power the LED. This time, we'll connect the LED circuit to a digital output pin on the Arduino Uno. Using the digital output pin on your Arduino is similar to using the push button that you used in the previous activity. However, you can control the digital output pin of your Arduino by programming it. The schematic looks very similar to the LED circuit that was built for activity 1. However, instead of connecting to the voltage source pin of the Arduino, we will connect to Arduino pin 7. Here's what your final circuit should look like. Once you finish watching the video, you can come back here to verify that you've built your circuit correctly. To build your circuit, do the following. Insert one end of the 1 kilo ohm resistor into D5 and the other end into D9. Insert the long leg of the LED into E9 and the short leg into E12. Insert one end of a jumper wire into A5 and the other end of the jumper wire into pin 7 of the Arduino. Insert one end of another jumper wire into A12 and the other end into the ground pin of the Arduino. There are many tools that you can use to program the Arduino, but for this class, we'll be using the Arduino web editor to program your Arduino. When you program the Arduino, you give it a set of very detailed instructions that it will follow once it's powered up. The instructions come in the form of various commands and functions that make up its programming language. Each program you write is called a sketch. Once you write your sketch, you will upload it to the Arduino. Let's write a sketch and upload it to the Arduino. You can find the code for this activity in your activity booklet. You can also copy and paste the code from the class website. To program the Arduino, do the following. Open your web browser and go to arduino.cc. Then go to Software, Online Tools, Arduino Web Editor, New Sketch. Click on the default name that was created for it and rename it blinking_LED. Note that sketch names can't have spaces. Then click on OK. Now type the code as shown in your activity booklet. Plug the USB cable into your Arduino Uno. Next, plug the other end of the USB cable into your Chromebook. Once you plug the USB cable into your Chromebook, if it doesn't recognize the Arduino Uno, click on the down arrow, select Other Board and Port, search for the word Uno, click on Arduino Uno, then click OK. Once you finish typing your code, click on Verify and Save. Then click on Upload and Save to program the Arduino. Once it's finished, you should see the LED start turning on and off. Typically, the Arduino performs each line of code in order from top to bottom. Now let's take a look at each line of code and understand what's going on. Anything between those slashes and stars in lines 1 through 3 is ignored and used for commenting and taking notes. We'll talk about this later. At the very minimum, all Arduino code has a setup and a loop section. Everything in the setup section only occurs once, right after the Arduino first powers up or right after it's programmed. Everything in the loop section occurs over and over again. The pin mode command tells the Arduino that pin 7 will be used as an output. That means that we'll be able to control the pin. Note that if we wanted to use a different pin, we could have replaced the number 7 with whatever pin number we wanted to use. The digital write command tells the Arduino to provide 5 volts on pin 7. This is equivalent to connecting the LED circuit to a 5-volt voltage source. Here's a visual representation using schematics of what's going on when you use the digital write command. The delay command causes the Arduino to pause for however long you tell it to. The number between the parentheses is the pause time in milliseconds. A pause time of 1000 milliseconds is equivalent to 1 second. In line 12, we're using the digital write command again, but note that instead of a high state like what we used in the previous digital write command, we're using a low state. That means that instead of providing 5 volts at pin 7, the Arduino will provide 0 volts. This is equivalent to not having anything connected to the LED circuit. On line 13, there's another 1 second pause. After performing the 1 second pause in line 13, the Arduino goes back to the first command inside the loop, which is the digital write command in line 10, and starts all over again. If the LED doesn't start blinking once you program the Arduino, do the following. First, double check your circuit and make sure everything is connected correctly. Then, verify that the long leg of the LED is inserted into E9 and the short leg is inserted into E12. If that doesn't work, try inserting a different LED. And finally, double check your code. Now, try building the circuit and programming your Arduino.